So, Pavel, do you want to repeat your introduction on record again?
People here, so
Oh.
not for the stall. Not for the
For the live stream, okay. So we're Tyke and we are ready to roll. So again, hello everyone, welcome to our office. I am really surprised how this topic is attractive. I'm really glad you came. I hope that we, with Cedric, everything's okay, that you will gain some knowledge, and also I'm looking forward to sharing your knowledge with me after the talk and telling me that we are doing the stupid way and we should do it better. So I will be talking about upgrade strategies of Kubernetes. We are mostly in cloud, so it will be mostly managed Kubernetes, but I think the strategies will apply to if you do it the hard way. Quickly about me, I am in Kabula for 16 plus years. I stopped counting, but the journey is fun. I switch roles quite often, every 5 or 6 years. I change what we do. We grow from 4 people to 160 people recently, so it's always fun. I've been working from Prague and Vancouver, now remote from Liberec. I started with front and back end, and now last 4 or 5 years I focus on infrastructure and SRE. We have a blog at 500.kabula.com. It's called Internal Server Error, so don't worry, it's not server error, it's the name of the blog post. And I will be sharing a new post later this week, I hope, with this topic. So if you want to clarify something, it will be there, not the slides, but the whole write-up, so like a little bit more in detail. So I have a quick survey. I have a couple questions. I have prepared them. Oh, there's someone else coming. Hello. Good evening. There's beer and there's toilets. So please raise your hands. Oh, not this slide. Go back. Who is running Kubernetes in production? Good, good. Who is running managed Kubernetes? Who buys Kubernetes from a major cloud vendor? Great. Who is running the latest 1.34 version in production? Who is running the next 1.33? Okay, it's time for upgrade. The time's running out. Who is running 1.30 and older? The past end of life version. Okay. Are you planning to upgrade? When? Okay, later. Q5. Correct answer. Who has a fully automated upgrade process? You don't have to touch anything to have the upgrade come through and upgrade all your control planes and nodes. Great. I want to talk to you guys after the talk. That's awesome. Why are you here even? You know everything. You have everything dialed. So let's get to the basics. Kubernetes is released every 4 months, and every version is supported for a year. So when the new version is released, there's already end of life date set to the stone. Cloud vendors are lagging behind a little bit. So for example, AWS does not have support for 1.34 yet. They are on 1.33. So you have to we are running Kubernetes clusters on all the 3 major cloud vendors. So we have to keep track on which cloud vendor has release dates, when their end of life is, and RSS is dead. So we have to track all that manually. It's not a lot of work, but you have to check those pages regularly and figure out what is the date to plan the upgrade. Also, GCP has a cool feature called auto upgrade, which forces you to upgrade your control plane. Sometimes you can configure it so it upgrades only on control plane to a new version automatically. So you cannot opt out of the automatic upgrade. So if you have your clusters in multiple cloud vendors, GCP for us is the date that we have to follow. We have to know when GCP has the auto upgrade date, and we have to upgrade before that, because we don't want to be caught up by that auto upgrade. So, upgrade strategies. What is the first strategy? Do not upgrade. Yeah. I'm looking at you. Yeah, okay. Yeah, like we would be here for a long, long time naming all the. Okay, so +3 minors. Okay. Okay. So, no upgrade. If you decide you don't want to upgrade, Kubernetes has support for that version for 1 year. What to do after that? Some cloud vendors, they do extended support for another extra year. So after they release their version, and they 1 year after their release, they stop doing the regular support, and then you can buy 1 extra year. It usually costs around $400 a month per cluster. So if you have a lot of small clusters, it's quite pricey. If you have one large cluster, it could be something you can do. If you need more, we will talk why you may need it after in a bit. You can buy Canonical 12 years long-term support, which is quite good, I think. Like, I don't know the price, but 12 years, that should give you plenty of time to figure out what to do next if you don't have the power to do the upgrades. At the last KubeCon, I talked with a guy from Canonical. I was interested in the 12 years long-term support. What do people usually do after that? And he said, oh, we're not there yet. Kubernetes is not 12 years out, and we don't have the support for such a long time. But he said, we expect that that the clusters will either die, they won't use it anymore, or they will do a major upgrade, switch the old cluster and start a new cluster. They don't have, he doesn't think that they will do like an incremental 12 years of incremental upgrades. It's not doable. So what are the pros and cons of the no upgrade strategy? Pro, it's predictability. You know, your cluster is running, nothing's changing, your workload will be running, it's perfectly fine. When you're still under the long-term support, the vendor guarantees the support. You pay for it, the extra year in then the major cloud vendors, or 12 years in Canonical. It's also very simple. It's also very simple to operate. There's no operations. It just runs. You don't have to worry about the upgrades. The cons: you are accumulating technical debt. That means that after your EOL kicks in, after 2 years or 12 years, you have to figure out what to do. Like, there's a lot of new stuff in Kubernetes, and you have to figure out what to do, how your application will react to it. There will be lots of new features that you need your application to accommodate. Also, you are risking vendor lock-in. If you are, for example, you're buying extended support from AWS, you can't switch to GCP because they don't have extended support at this time. What I think is the no upgrade strategy good for? It's for regulated environments. By that I mean, did I hear something? Okay. What I mean by that is that if your application, including infrastructure, has to go through some certification, and the certification takes a long time, you don't have time to upgrade every 4 months and do the certification over and over again. So in a situation that your application needs to be certified and the certification takes 1 year, it may make sense to buy the long-term support and stay at one version and work on the certification for another year and then upgrade after a year or two. Maybe you don't have operations capacity to the upgrade at the moment, so you can stick to a version for a bit until you have more people to do the upgrades. Or maybe you don't plan to use the cluster for more than 2 years, so maybe you pay the $400 a month and then you will turn it off. So it's perfectly viable strategy. But maybe you want to upgrade, you want to keep the cluster running for a bit longer. The screenshot is from Azure AKS control plane upgrade dropdown, where my automatic upgrades are disabled. You can enable patch versions, stable miner, rapid miner, and node images for security updates, but we have it disabled, and you will know why. So, when you want to make an upgrade, I would recommend planning for it, do some research in advance, especially if it's your first upgrade or you don't have a runbook or routine for that. My first suggestion is turn off auto upgrades. They can catch up with you, or they can surprise you at the moment you don't expect it. They can cause you some downtime, so turn it off and then start figuring out how do you do the upgrade. Read the release notes. Read the release notes of Kubernetes. Read the release notes of your cloud vendor. Read the release notes of all the workloads you have there, so you know what the upgrade means for you. Sometimes there are I see some heads nodding, so there are some bad experience there. There can be some hidden gems in the documentation that you don't know from top of your head, and you need to know what to prepare for. You can use kubectl deprecations or Pluto or Cube, no trouble. Cedric will talk about it, so I will not go deep into it. That's perfect tool for Cedric. Where are you? For Cedric's talk. Also, the image there, that's something we keep track of manually. That are some of the workload that is running on an EKS cluster in AWS, and we every component has a compatibility matrix, so we know. So we are right now at 1.32, let's say. So I know which component is supported, will be supported in the next version. So I know that before upgrading to 1.33, I need to upgrade Kubernetes Autoscaler and kubeproxy and core DNS. Calico is fine. The current running version supports 1.33. So before you even start doing the actual upgrade of the cluster, you have to upgrade, if possible, the workload that you are running there. While performing or executing the upgrade, some nodes and some workloads will be down. You have to prepare your workload for the disruptions. You have your PDBs dialed in. That means that everything, if it goes down, you may even test it in advance, do some chaos engineering, or just try how it works, and have your workload ready for migrating to a new node or to a different version of the cluster. Also, it is very good to have application tests. What we do, we have a testing cluster in each major cloud vendor environment. And before upgrading, we upgrade a testing cluster, run all the tests we have there. It's smoke tests, integration tests. It takes a couple of hours, but we are then quite certain that the upgrade will be pretty good. It's good to have some monitoring while the upgrade is going on, especially if you have multiple clusters. You want to know that something went wrong, and you can go and start fixing it. Prepare for rollback. It is rare, but it may happen. So it is good to know if and how you will roll back to the previous version and fix what is broken and that you missed during your research. You can also modify how the cluster and upgrade is executed. That means that you can, for example, configure node auto-scaling so that if your workload is drained and ready for a new version, then the cloud vendor will spin up a new node and put the workload there. Or you can change the drain timeouts during the upgrade so that your workload has enough time to go and schedule itself. Kubernetes has enough time to schedule the workload on a new node. Also, it's not your last time you're doing it. So create a runbook, keep it updated every time. You see we have 10 plus runbooks that we copy and update every time we do it. And we keep track of what went wrong, how we're doing, and next time it is a little bit easier. And when you finish your upgrade, start planning for the next one, because the new version is here in 3 months. It's coming pretty quickly. So you are prepared for the upgrade. How can you do it? Strategy number 2 is pretty straightforward. It's in place. This is a screenshot from Azure. You select a new version, and there's a upgrade button somewhere hidden here. It's a blue button. And you upgrade the control plane and all node pools. Who does that? Good. Does it work for you? So far, so good. That's pretty good. Like, you're saving a lot of time, your application is dialed in, everything is resilient. That's awesome. That's awesome, you can do it. So, pros of this strategy is that it's very simple. You just either change one variable in Terraform or click a button in a UI. It's very quick. The cloud vendor takes care of everything. It concentrates risk at just one moment in time and one place. So if there's an issue, it might be pretty hard to roll back. Also, if you don't test your application properly, there might be some possible downtime. If your PDBs are not set, maybe you will hit some drain timeouts on the cloud vendor's upgrade strategy. So if you test for it and you know your workload and it's resilient and predictable, it's easy. You can do it. Also, you can do it on all your non-production environments. Strategy number 3. So first one was no upgrade, second one was in place, third one is blue-green. So basically, you spin up a new cluster, maybe a whole new VNet with all the stuff in there, and you put a load balancer or a DNS switching, and you slowly switch traffic from one cluster to another. That is very safe. You can always roll back. You can switch the traffic going to the older version. You can test. You can spin up the new environment and test it properly before you switch traffic to it. And also, it's possible to achieve zero downtime even if you have some tricky workload. But it is very expensive. If you have some stateful workload, for example, if you run an etcd cluster or a MySQL database or Postgres database on the cluster you are migrating your traffic off, you need to migrate the traffic as well and live, because you are switching only part of the traffic. That might be tricky to figure out, maybe impossible, or maybe you need to put the database outside your cluster and buy it from the cloud vendor. Also, switching the traffic from the one cluster to another can be sometimes tricky. If you do it via DNS, there are some delays. So it is expensive, it is quite complex, but it is progressive. So you can switch if you are in heavy traffic environment. It might be a good scenario for you or good strategy for you, or you want to do it a controlled way. And also, I would vote for this strategy if your uptime is very critical and you need to minimize the downtime as much as possible. So, with all these 3 strategies, we figured out that none of those strategies suited us. So we had to figure out how to do it. For the long-term or no upgrade strategy, our issue was compliance. We couldn't live with older versions. We couldn't pay. We have 20 plus, between 20 and 30 clusters, and paying $400 for each cluster a month, that's not doable. And we have clusters that live quite a long time, so we want to keep them updated. In-place strategy proved to be quite disruptive to some of our workloads, so we couldn't just click the button because it will destroy some of our clients' work there, and we had bad experience with in-place upgrades in Azure. The blue-green strategy, it's very expensive on labor, on time, and effort to implement that and do it every 3 months. Also, we have some technical blockers for blue-green strategies. For example, in Azure, we connect with client networks using private links, and it's and both sides, and sometimes this can be tricky because we would need to do the traffic switching on client sides as well, so that's quite tricky. We have some workload that is not compatible with the blue-green. That means that, for example, one of examples which workload is not compatible, we run for our customers their IDEs for data analytics. That if you know Jupyter Lab or something like Streamlit, that's something that runs for 8 hours. The client does his work in it, and you cannot move it somewhere else because every stuff lives in memory, is on a hard drive with the pod, and you cannot move it somewhere else. You have to wait until his work is finished, and then you can upgrade. He asked only 8 hours. Right now, yes, but we learned it the hard way. We didn't have a limit, so now the customers are paying for the time, so they sort of want to turn it off, and if they forget, they were complaining, oh, it's too expensive, I forgot it running over the weekend, so we have implemented that it auto sleeps after 1 hour of inactivity. So that gives us some option that, okay, we cannot move it right now, but maybe in 8 hours this will be off, and we can start over later. Also, we have some stateful services in our clusters. We run etcd and Elasticsearch clusters, which switch it, and there's incoming traffic, incoming workload, or incoming data into that, and switching gradually from one cluster to another, that's too much. And we don't really have requirements for that. We can handle some minor disruptions. So what to do? So we figured out that we might do what we call incremental upgrades. That means that we separated upgrades of control plane and data plane. So we upgrade control plane first. That's pretty easy, pretty straightforward, obvious. In one of the screenshots you can select that I showed, there was upgrade control plane or control plane plus nodes. So we just, in the UI or in Terraform, we upgrade the control plane that goes to a higher version. And then I'll keep this picture. It's simple. Then we use in every cloud vendor we use node pools, and we separate our workload to node pools, depending on how the traffic behaves. Like for example, how the traffic behave, or how the workload behaves during an upgrade. So we like the workload that I was talking about that cannot be moved lives in a separate node pool. All other workload that can be drained and moved lives in a different node pool. So we have different node pools handling different node of workloads, and we can apply different strategies to each of those node pools. What we do, what we figure out is the best, and it has also some other benefits I will talk about later, that each of those node pools has an A and B variant. This is like blue and green, but it's not the whole cluster, it's only the node pool. And we switch workload between the A and B node pool. It might seem complicated. I have some detailed graphs to go through, and you will understand how it works. So separate control plane, data plane upgrades. We group the nodes into node pools depending on the workload that has special needs, and we have different strategies for each node pool. Then we can use drain or cordon. If there's a new node pool, then we can drain or cordon the old node pool. And if that doesn't work, and we have workloads that don't support that, for example, that Jupyter Lab, we can use custom strategies. That means it's a simple script that goes and waits or moves the workload according to their needs. So it's very simple to inject a custom script that is kubectl, do whatever you need to move that workload somewhere else to a new node. It is all this process, upgrading the cluster, can be orchestrated via Terraform, and those migration strategies, the script that moves the trigger workload, today is very easy to implement using AI. I put up a script a couple months ago that handles the tricky workload, and it took me just 1 or 2 hours to make it production ready. So it helps a lot. I will go into details of the strategy in a few slides. What are the pros is that it combines benefits of all the previous strategies. You have granular control of which workload is upgraded in the way best suitable for that workload, and you have the flexibility to do the custom stuff you may need. There is still some operational overhead, but we are working on fully automating that. You may, for your tricky workload, you may need to figure out your migration strategy, and the rollback is still limited because you are not switching traffic that can be switched back very easily, but you are switching the workload to a new node. And this is best for, I would say, tricky workload if your workload doesn't behave the way, so you can do the in-place upgrade, which is it's awesome that you can do it. And also if you can handle some critical outages, or they are quite rare. So I'll go through a quick comparison of all those 4 strategies. The long-term wins almost everywhere, but except for yeah. And the blue-green is the safest and slowest and most expensive. The in-place is the fastest, but quite risky. And for us, the incremental is sort of, you can see it. It's in the middle and supports our tricky workload. So that was the winner for us. So how does it actually work? I will show you some implementation details of that strategy in GCP and Terraform. So I guess, guys, you all know Terraform, right? Even if not, there's a few lines. So for each, let's say we have a cluster, Kubernetes cluster, which has only one node pool. So we have a variable for Kubernetes version, that is the control plane. We have Kubernetes version for A and B node pool. And we have a switch that tells the workload which of those 2 node pools is active. This value is the value of node pool main active is A or B. Then we have a local array of node pools where this set of variables is expanded into an array, and this can be, it's quite long, but what is important here is the taints here, that if the node pool is active, it has no taints. If the node pool is not active, it has disabled node pool taints, which look like this. It's simple. It does not accept any workload. So that if you have auto-scaling set up, the turned off or inactive node pool does not have any workload and does not have any nodes running. So it's basically off, and you can do whatever with it because there's nothing. And then there's the node pool Terraform implementation. It's basically a loop. And what is interesting here that the node pool has its own separate Kubernetes version apart from the control plane, and it has this dynamic field with the taint. That's the core of the implementation. So let's go through the process of upgrading, doing the upgrade in pull requests and making it work almost automatically. So this is the initial state. We are running the whole cluster in 1.32. The control plane is 1.32. Both node pools are 1.32. Active node pool is A. Oh, hold back. Is A, and it has some active workload. My first pull request is upgrade the control plane to 1.33. That works in place, works fine. We didn't have any issues. And also upgrade the inactive node pool to 1.33. That inactive node pool does not have any nodes, has no workload. So it's just a method of operations, very quick, nothing happens. You can merge this happens, you wait for upgrade of the control plane in Azure. The upgrade of the control plane takes about 10 minutes, and then you're done, you are ready. Then, pull request number 2 sets the node pool main active to be. That means that at this point, it will assign the taint to pool A and remove the taints from pool B. So any new workload will move, or any new workload will be scheduled on pool B. But any current workload will still remain on pool A, and you have to switch it over somehow, and that could be orchestrated by kubectl drain or kubectl cordon or the custom strategy I talked about. You can create a script that will move the workload to a new node, which has the same node selector, the same labels, but has just a different taint for being active or inactive, and you can write a script in whatever language you want to move that workload safely according to your rules. You don't have any limits on how to do that. So that workload is moved, and you can run that either from a pipeline or locally, or maybe there is a way how to do it using taints and tolerations, but we are still not fully automated here. We have a script that does this, and that script will run in a pipeline. So once your workload is moved to the new node pool is running on 1.33, then the old node pool A has no nodes, has no workload, and you can safely upgrade it to 1.33 as well. That happens pretty quickly because there is no running workload, there are no nodes. So your switch is over, everything is running on 1.33, and you are safe and everything's done. What I really like about this approach is that this does not only apply to Kubernetes version. You can use this strategy to upgrade node parameters like disk size. You cannot change disk size in place or on the fly. You have to create a new node pool with a new disk size or something like that, and you can easily use the same set of 3 pull requests and the same pipeline for the draining or moving the workload to change parameters of the node pool. This is fully automatable. There are 3 pull requests, but you can have a script create those 3 pull requests. You have to, if you have some tricky workload, you have to write a custom script, but you can have some pipeline to run that script. Last time I did upgrade of our 10 Azure production Kubernetes clusters. I still run the scripts manually, but next time, which is in December, I think, I will try to run them in a pipeline. So this will be fully automated, running in parallel, and all I will be doing is sitting and watching that it works. Also, this scales pretty good, so if number of clusters grows, you can do this in parallel and run it everywhere you need. If you have only 1 cluster, you may not need it, but if you have 10 clusters or more clusters, having something fully automated and safe is pretty nice. So how are we doing with time? So I have. Do you guys have some questions regarding what I talked about? Mm-hmm. Yes. It will scale down automatically. We have auto scaling set up, so if there's no workload, the old node pool will scale down to 0. Yes, the node pool is there, but has 0 nodes, exactly. Yes. So if we have 5 node pools, 5 logical node pools, there are 5 times 2 variants of the node pool, and half of that is running workload, half of that is just empty and waiting for the upgrade or any update to happen. Let me go back a few slides. I think most of the workload that needs to be upgraded with Kubernetes version is this slide. Has support for multiple Kubernetes versions. So we upgrade before to a version that supports like the old Kubernetes version and the new Kubernetes version. Yes, exactly. We do it in advance. So before I start doing the pull requests, all the workload that is there supports the old and the new version of the Kubernetes. Mm-hmm. That's a really good question. That's a really good question. Why we used taints instead of node selectors? Because we have multiple node pools, and our applications work with the node pool selector as well, because we have an operator there that spins up a custom workload on a new node, and you would need to update that application or configuration of that application every upgrade, and that might take some time. So we want to shield the application from this change. So that's why we use taints. And it's also easier to roll back because you would remove the taint and switch the taint. You don't need to modify the application. It's all metadata in the cluster. But if you have only 2 node pools or 1 node pool and you create the A, B, or blue variant, it might be sufficient. But you will need to implement that in your application or in provisioning of your application and switch. When you're switching the active node pool, you would need to switch where the node pool selector as well, or the node selector as well. Mm-hmm. Mm-hmm. How many services were you running? And you changed the node selector in all of them at the same time. Okay. 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 I think the main reason is that we had multiple node pools before that, and it would be this seemed like a easier way, but this is perfectly good as well. Any other question? Okay. We use it somewhere in some parts of the application. I don't know if we're migrating fully to OpenTofu or not, but we are using it somewhere for some features that Terraform doesn't have, if I remember that correctly. So I have a bonus slide talking about security updates. Are you good enough, or do you want to go into security updates? It's one slide, just going briefly into that. Okay. On the contrary, compared to Kubernetes version upgrades, you want the security updates to be fully automated. You don't want to do that manually. You want to, as soon as your cloud vendor puts a new image or a new update, you want to have it on your cluster, and you don't want to touch it. Some cloud vendors, they support it. Some cloud vendors, they send you, oh, you have a new image, you have to upgrade your cluster. So, for example, in Azure, that is fully doable in 2 ways. There's, again, the screenshot from Azure. The last item above disabled is enabled with node image. That basically upgrades your cluster with new node images when the new security update is there. Or what you can do, or what Azure does, is that they prepare the upgrade on the node itself. and then they tell you there's a new update ready, and then you can run Kubernetes reboot daemon to reboot the instance, and that will work as well. We have quite a good experience with that. It works even without tricky workload. It's a little bit of configuration, but basically what it does, that when there's a new security update ready on the image, Azure puts a file somewhere on the disk. Kubernetes reboot daemon waits for the file and then reboots the node, drains all the workload of the node and reboots itself. In AWS and GCP, it's a bit trickier. In GCP, you have a completely new Kubernetes version that you have to upgrade, but you can do it automatically using the strategy you have. And AWS is very similar. They create a new image, and you have to. It's very similar to upgrading a Kubernetes version as well. So you want to do this automatically. Do you have any experience with security updates, and do you do that often? Do you have your clusters up to date and your nodes up to date? Maybe. Maybe yeah. If you're not forced, then the Kubernetes lifecycle forces you to update every 3 months. Maybe that's good enough for your environment. That's doable. Yeah. I like that in Azure, it just upgrades automatically, and it does like they have a new security update every 2 weeks, so you know that you're up to date, and that's something good to put in your SOC 2 audit. So that's it. That's everything I wanted to tell you. If you have any more questions, are there any questions on Slido? Sweet. Can you repeat it? Can I read the question somewhere? Okay. Stateful set. Our experience with stateful sets, that's etcd and Elasticsearch, it works pretty fine. It is usually spread across multiple nodes. If you drain a node, it schedules itself on a new node. Now, regarding this particular workload, we didn't have to build any custom strategy. It works pretty good out of the box. We didn't have any downtimes upgrading etcd or Elasticsearch. And daemon sets, usually they start when a new node is started. It does its work, so I don't know about any specifics when upgrading Kubernetes version for daemon sets. Maybe you can expand on that question or ask me later. The second question. Oh, yeah, I'm reading it, and I'll be reading it out loud. How do you deal with exhaustion of Docker Hub limits on containers download during upgrade? For example, some component image downloaded at every new node. That's a good question. Use private registries. Yeah, that's the best. But still, we do have some public registries, and when upgrading 10 nodes at a time, we don't hit that often. I can't say we don't hit that limit, but it's not that often. Which image? Ideally, that one in your cloud vendor. Yeah. Otherwise, you would pay for traffic. But we use only one and pay for traffic. But you want to have like the registry in your cloud vendor in the same region that is fast, that is cheap. So thank you for your time, and I'm looking forward to Cedric's talk. Beer.
Break and start with the second talk. Okay, everyone. It's time to continue our journey today. Please sit down. And we are about to start. Yes, I have no image. Oh. Hopefully it's not here. Hello? Hello there. Yes, I have image and I will project it. Yes. Here you go. Okay, please.
So, hello everybody. My name is Cedric, and today I'm going to talk about a specific topic about Kubernetes upgrade, which is how to handle the deprecations and removals done by the upgrade of Kubernetes. So first, let me introduce myself to you. I am working at Cloudera, but before that I was working for 7 years at Tycoon, and we just got acquired by Cloudera. As you can guess, based on my accent, I'm coming from a country called France. I hope you can understand me, but if there's some problem, I can repeat, and I'm sure we will be able to understand each other. So what is a Kubernetes upgrade? That's a very good question. So Kubernetes upgrade is to go from one minor version of Kubernetes to the next one. So Kubernetes versions, they have three numbers. The first one, we never care. It will stay the same for some time. Of course, there are some talks about Kubernetes 2.0, which possibly will find an alternative to YAML, but this is not going to be for now. The second number is what we really care about. This is a minor version. And finally, the last one is the patch version. No need to really care about it. So we are talking about upgrade from one minor version to the other one. The upgrades include new features and improvement to Kubernetes. They also can deprecate and remove some APIs, and they can provide security updates and bug fixes. When you let me check. When you are in the same minor version, but for example moving from one patch to another one, there should be no breaking changes. Now, about the components which are upgraded in Kubernetes. So this is your typical Kubernetes cluster. Even on the cloud providers, it looks like this, even if you don't see the control plane. So you have the control plane, which is running various services like etcd, which is the database of Kubernetes, the API server, which is the part which we will focus in this presentation, the scheduler, which roles is to schedules your workload on various nodes, the controller manager, which is reconciling the state of the cluster compared to how it is right now and how it should be. Then on the nodes, you have various components. Kubelet, which role is to make sure that the containers in the pods are running. You also have a Kubernetes proxy, which is handling the networking for services. And finally, if we want to really simplify it in the most extreme way, the container runtime interface. So when we talk about Kubernetes upgrade, all these components are upgraded. In the case of like the ones really which are affecting Kubernetes directly are the API server, the scheduler, the controller manager, kubelet, and you can also change version of etcd, of your container runtime, but this is not the direct Kubernetes upgrade. As we could hear in the previous talk with Ondřej, sometimes upgrading Kubernetes is complicated, but why do we upgrade it? As it was mentioned, it's important to fix the security risk. if you work in certain industry, you need to have some compliance. And staying a lot behind in your Kubernetes, if you skip many Kubernetes upgrades and keep having an old version, it can lead to some problem with operations and maintenance. Maybe there will be some bugs in this version which will be solved in some next version, and you will be stuck. And nobody will be able to help you because you are running something which is really old and nobody is using it anymore and nobody will care. Also, the technical debt. And it was also mentioned here, the cost. One cloud provider, which I won't say the name, started to make people pay more money if they don't upgrade. It can go up to six times more compared to an upgraded cluster. And the question is, do you really want to pay 6 times more for the same Kubernetes? Some of you can afford it, some of you don't care, but in the end, I don't think it's worth it. The Kubernetes APIs are moving relatively fast. There is a new release every 4 months, and these releases are bringing new features, but they also deprecate resources. Here are some examples of resources which were deprecated or removed in the past. For example, deployment and replica set, they switch from extension v1 beta 1 to apps v1. Ingresses, post security policy, this one was completely removed. So if when upgrading your cluster, you didn't really care about it, you could lose compliance because post security policy was simply removed. And recently also, maybe a year back or 2 years ago, cron jobs was moved from v1 beta to v1. And the goal of this talk is to show and demonstrate what you can do as a Kubernetes user or administrator to mitigate these API changes. So the first one is pretty simple, and maybe many of you are doing it. Who, when upgrading Kubernetes, is looking at the release notes? Only? Otherwise, you don't care, like if you are fine with surprises? Yeah. It's okay. We also like surprises, and what could go wrong, right? So after looking at the release notes, you can compare it with your manifest and go file by file and see what should be changed. It starts to be complicated if you have a lot of files. And it gets even more complicated if you are using Helm charts, because, okay, you know what is deployed by the Helm charts. You can look at the repository of a Helm chart, but if they have dependency, it means you also have to look at dependencies, and if these dependencies have dependencies, it goes on forever, right? You also have to look at the CRDs, so this is really, really complicated. And if you are fine with surprises, this is okay. But if you don't want to have any downtime or to let yourself be surprised, I don't really recommend this approach. So here comes the first tool of today, Kubent. Who heard about it out of curiosity? That's some people, that's good. So Kubent stands for Kube No Trouble. I guess you have an idea why it's called like this. The idea behind Kubent is to avoid you to have any bad surprise. You can run it in your cluster, and Kubent will basically scan your cluster and look for resources which will be deprecated in Kubernetes. The advantage of it is that it's very simple to use. And let's do a demo. So I created just before this presentation a virtual machine in cloud provider, and there is nothing now. For example, if I do kubectl get nodes, nothing. I prepared a script to install a relatively old version of K3s. (1.24) is relatively old, maybe 3 years old. And spoiler, in version 1.24, there are some objects which will be deprecated in the next Kubernetes version. Okay, we have a cluster ready, so we can look at the nodes. Perfect. So as an example, we have here some cron job called hello cron job 2. And as you can see here, the version of it is not the one you know. Usually it will be, I think, something like batch v1. And here is batch v1 beta 1. So I'm going to create this cron job. The resource is still supported in this Kubernetes version, but it will be removed in the next one. So let's see how it will behave in Kubernetes. Okay, it got created, but you can see there's a warning that this resource type was deprecated a few Kubernetes versions ago, and it will be available in the next Kubernetes version. But still, Kubernetes allowed me to create it, and if I didn't pay attention, I will not know about it. Or if I had some automation of deployments, I will not be aware about it. Okay, now we are on the GitHub page of Kube No Trouble. It's amazing. There is some one-line installer, and nothing could go wrong, right? No. Of course, yeah, for the demo. So I blindly trust them, and I'm going to run it on my VM, and let's see what happens. Ooh, shit. Okay, I really hope that nothing was bad. There is no Chinese hacker or no Bitcoin being mined there. Looks good. So now there is some binary installed here, Kubant. So let's try to run it. So we can see that it detected that there is in the cluster one object which is using deprecated API version, batch v1 beta 1, which will be batch v1. It tells me the namespace of the object, its name. If I want to go further, I can say, okay, I want to move maybe to some different Kubernetes version, because now it was showing me that the target Kubernetes version, which it is comparing it to, is the current one. And let's imagine we want to move to the next Kubernetes version, so 1.25. Although 1.25.1. So same output, of course, that this version will be deprecated. So it means if I try to upgrade my cluster and I create the same resource, it won't work because it was removed from the Kubernetes API. Now let's do some other scenario. Let's see how it will behave if it was in 120, which is 4 versions ago. if I wanted to apply this resource in 120, there will be no problem. It also supports more options. For example, if I just want to check a file or a manifest I want to apply in my cluster is valid, I would just specify that cluster no, I don't want to analyze my cluster, I just want to analyze this file. And it will tell me here that the file here contains an object which is not valid, which is using deprecated Kubernetes API. So personally, I really like kube-no-trouble because it's extremely simple. Anybody can run it. You can install it in a good way by downloading a binary, not by, of course, running this kind of one-line command. And you get an overview pretty quickly if in your cluster you are running some workload which is deprecated and there's a risk that it will be removed. And extremely simple to identify it, so I will recommend for this use case. That's a good question. Let's make something like export qconfig maybe, or unset qconfig. It's broken, yes. Yeah. The link was given by my colleague, so it's his fault. Kidding, of course. Yes, it is possible, and actually this is a very good use case for it. If we try here the H, you have this option here, exit error. So if you have this option, it will fail with some exit code other than 0. And for instance, your CI pipeline could fail if you are trying to apply some manifest which contain wrong version. Okay. So the next one is called Pluto. Have you ever heard about it? Nobody? Except Ondřej? Yeah. So Pluto works in a similar way as kube-no-trouble. In my opinion, it's a bit more complete. You can have more use cases, and it's especially easier to integrate in your CI/CD pipelines. And the idea is the same. You can detect deprecated APIs in the cluster, and also in CI/CD if you integrate it to your pipelines, and it can help you to catch issues with Customize in CI/CD or with Helm when you make a commit to your repo. And let's make a quick demo. So here, sorry for you, there is no one-liner. I made a script with AI to download Pluto and install it. So let's do that. Sure. Okay, so Pluto is installed. Pluto is installed. So let's try to see what's happening. There is some option which is detect all in cluster. And we get a result very similar to before. We can also try to, it's also supposed to work with Helm charts. So I prepare some Helm chart which is containing some wrong wrong API versions. And here, Proto is able to detect that basically I installed just now a Helm chart cron job alt, and the release name is test. We can see here with analysis of Proto that this Helm chart test has this resource test cron job alt, which is deprecated and which is to be removed, and there is some replacement available, and the replacement is badge v1. So really easy to see what's wrong. So this is the case of in-cluster configuration, but we can do the same. Let's say we work with Helm chart, and someone in the team wants to modify the Helm chart or to add something there, and let's try to check the issues with Proto. So this is a simple Helm template. Helm template, for those who don't know, is simply generating the manifest, rendering the manifest of the Helm chart. Let's feed it to Proto, and here we can see Proto detects that what I want to apply. You can see the release name, because release name is the default name in Helm. We'll create an object which will be invalid. So what makes it really easy to integrate to the CI/CD pipeline is that it returns some non-zero code, and the pipeline will fail, and like this you will be able to identify that you are going to apply something wrong to your cluster. So these two examples cover the cases where you want to look in your cluster and see if there's some resources which are deprecated, but it doesn't prevent you from adding resources which are going to be deprecated or removed to your cluster. And this is the idea behind using Gatekeeper for this. So Gatekeeper, just imagine it as some kind of customizable admission controller for Kubernetes. You can define policies and constraints using a language called Rego. There are really many things you can do. Typical use cases, for example, you don't want any image in your cluster to run with the tag latest, or you want to have a whitelist of ingresses. Let's say you want that ingresses will be only, I don't know, example.com. And Gatekeeper will work in a way that it will reject and deny the creation of resources if they don't comply with the rules. What we'll do in this demo here is configure Gatekeeper in a way so that it will block the creation of deprecated API resources, which we'll specify. I prepared a script here to install Gatekeeper. Basically, it's about adding the repository and doing Helm install, and that should be it. So let's wait for the installation to be completed. Okay, we can see that there are 4 pods running in the Gatekeeper system namespace. And now let's go to the next step and look at some files. So this is the first part of the configuration. We create what is called a constraint template. Here we will call it KTS deny job. And the idea of it is to look at every object creation in the cluster and to look at its kind, its group, and its version. And here, if it will match cron job, batch, and v1 beta 1, to basically reject it with some error message here. Then the second step is also very simple. It's about creating a constraint. This will just tell Gatekeeper to enable the constraint template we created just before. So after we create this, it won't be possible anymore to create cron job using the old API version. So let's try it. Here we have a cron job named bad cron job 2, and let's try to apply it and see if it works. No, it doesn't work. And you can see here that Gatekeeper rejected the creation of a resource, and we can see the exact same error message as we saw before. So with this approach, you will be sure that no new object of a type you want to forbid will be created in your cluster. And we can try now to create a good cron job, and it should work. Good. And it works. No? Good job. Yeah. Okay. So we saw 3 ways, I mean more like 2 ways, how to make sure that there will be no deprecated API resources running in your cluster. The first 2 were more like were more like with observation to analyze what's in your cluster, to maybe block the merge of your Helm charts, and Gatekeeper was to really prevent the resources from being created. So do you think if you follow this approach that it will be enough? In theory, it should be no. So, to be honest, no, it won't be so smooth because there's a little surprise. It's called Kubernetes operators. Because in Kubernetes, we have something amazing called operators. And the problem of operators is that they are complete black boxes. You have no idea what they do. Maybe your operator is amazing, maybe it will work, but maybe it is not so amazing. And there are chances that in the source code, it is calling Kubernetes API and creating or calling it with resources which are deprecated. And the only way to really check it is to either go to look at the source code or to test your operator in an upgraded cluster. So I want to wish you a good luck with upgrading, and if you have any question, I would be happy to take them. You can do that, it also works, yes. When, yeah. So, to be honest, at the start we didn't really care, so we were fine with having surprises. But now, before upgrades, we like to run cube no trouble. We found the approach of gatekeeper to be really heavy, because in theory you are fine if you look at the change logs, and Kubernetes API is moving pretty fast. But if you look at the changelog, there is no real big reason that you will be caught by surprise. And in our case, we are running first the upgrade in a dev environment, and if something is broken, it's okay, we see it and we can fix it. So we don't really create the constraint with gatekeeper. Okay.
You can see it here. I will read it aloud. How does upgrade cluster button in Tycoon work? Is it more or less dependent than Azure counterpart presented in the previous talk?
Okay, good. I'm happy to see a question about the product we are working on. So it's called Tycoon. And in Tycoon, we follow the approach that we don't really use the hyperscalers or the public clouds Kubernetes. Tycoon is a platform which deploys Kubernetes on multiple cloud providers. It can be the big public cloud hyperscalers like Amazon, Azure, Google, but we also support private cloud. And our idea to avoid any vendor lock-in is to not use their Kubernetes, but to install our Kubernetes. So we are creating the VMs, we are creating all the resources, and installing our own Kubernetes distribution. At the beginning, we had the feature of auto upgrade, which was mentioned before. And we quickly realized that nobody wanted that because things got systematically broken. And every 4 months upgrade, it's really sometimes, of course, this is the good practices, but this is too intense for some of our customers. They don't really have big teams. So we dropped that. And to go back to the question, how do we handle upgrades in Tycoon? We do it with a rolling upgrade. We upgrade 20% of the cluster at the same time. So it's like in place upgrade, but the nodes of the cluster get drained, and the Kubernetes components are upgraded there in place. And once the upgrade of these nodes is done, they are untainted, and the workload can come back and the other nodes can be upgraded.
Okay, next question. Kubernetes or Pluto in the live cluster or in pipeline?
I want to say that it's not black and white. These tools are good for both use cases. It's very nice to know that if you are using something deprecated in your cluster, and it's also excellent to block the changes which are in your Git Helm charts or manifest before they reach the cluster.
Which of the detection tools do you prefer, Kubernetes or Pluto, and why?
So to be honest, my preference goes more towards Pluto, because I believe that it's a bit more complex. It can detect directly the Helm chart in the cluster. It's able to tell you from where exactly the resource which are wrong are coming from.
Okay.
Why is OPA Gatekeeper heavy? I think you could see when I installed it that there were already 4 pods for Gatekeeper, and I would say it's heavy because you have to write the resources. You have to write the template, the constraint, and it depends what is your use case, but for simple use cases, in my opinion, this is really overkill. That's a good question. I didn't really see it in the documentation, so I don't really think so, but maybe I'm wrong. There was some hand at the there. That's a good question. Both are doing, both OPA Gatekeeper and Kyverno are doing something similar. I didn't play so much with Kyverno. I think it could really do the same thing as Gatekeeper here very well. But I think that in some cases, Gatekeeper might be more flexible because you have the complexity of Rego baking it. But this is my own opinion. But here, I think this was really overkill to write something with Gatekeeper to block the admission of specific Kubernetes resources. I will say that most people are using Gatekeeper for something else, like the use cases I described before, to prevent latest images, to pull images only from some given repositories, to forbid noteboards maybe. So this is really an extreme. I just wanted to show, okay, this is possible with Gatekeeper. And my question now, who is going to use Gatekeeper or these tools now? Okay. Thank you very much.